All right, everybody, welcome to part two of early numeracy problem solving. So where we're working on word problems. All right, so now we're going to go over the three different types of problems for addition and subtraction a little bit more in depth, okay? So first we're going to start with group word problems. And when you have group word problems, big things to remember are that you're combining two different things. Think about that. You're combining two different things into one larger group. And so what that is part, part, whole. If you've ever heard of that, I'm sure you've covered that in your math class, is part, part, whole. So let's look and see what that would look like in a word problem. So here we have again, Rowan's class is taking a poll on class pets. Rowan has 3 cats. He has 2 dogs. How many pets does he have all together? So if we look at this, Rowan has two different things. He has cats, he has dogs, and we're combining those into a bigger group, okay? We're combining those into a bigger group. So again, that is considered part, part, whole, and the parts are cats, dogs, and then pets altogether, pets. I want to caution you though, when I first learned about teaching word problems, we were taught to look for key words. And I want to caution you about relying on keywords because you're going to see in just a little bit that they can lead you astray. This is why we can use them to help support us in determining how to solve the problem and knowing what we're being asked to do. But this is why that problem structure is so important, is because you cannot rely on keywords alone. And so what I'm going to do is I'm going to stop sharing real quick, and I am going to show you what that procedural rule and those hand motions look like. And this is what it looks like. Small group, big group. And that's what you're doing. Those are the hand motions. So your procedural rule is small group, big group for a group word problem. And again, it looks like this. Small group, big group. Let's do it together. Small group, big group. Now do it by yourself. Excellent. All right, so that is your procedural rule for a group word problem which has different things that you're combining into a whole. And this is what your graphic organizer looks like. And you're going to see the researcher, Alicia Saunders, do this in just a minute. But what you would do, and you're making these motions that I told you about, is that you would do small group, then move them together, but you would show big group. So small group, big group with manipulatives, small group, big group. All right. And if you were doing this when you're teaching a problem and your problem is, I think, what did he have? Let's say 3 cats and 2 dogs. Then you would say 3 cats, 2 dogs, and then we know we're going to combine them. So add, and then you would count the total all together and give the number of pets. All right, let's look at our next type. Our next type is called a compare word problem. And when you're doing a compare problem, you have two things that are the same. So listen to that. That's a difference now, is you have two things that are the same. You're going to have a bigger set and you're going to have a smaller set. And when you are doing a compare, you're going to subtract. So think about that. When you're comparing things, you subtract one from the other to see the difference between the two, right? And so when you're doing that, here's an example again. Sydney and Cooper work at the car wash. Sydney washes 7 cars. Cooper washes 3 cars. How many fewer cars did Cooper wash than Sydney? And so if we look at that, they have the same thing. They have two things that are the same. They have 2 sets of cars. They have a bigger set, 7 cars, and they have a smaller set, 3 cars. And if we want to know how many fewer, and if we look at that fewer, that is called a compare phrase, and that helps us, but we don't want to rely on it again because we're going to look at the structure too. Then that helps us know that we're going to subtract. And so I'm going to stop sharing again. Let me see, we have 7 cars and we have 3 cars. And so our rule is bigger number, smaller number, the difference between the two. Watch that again. Bigger number, smaller number, the difference between the two. Let's do it together. Bigger number, smaller number, the difference between the two. Now do it by yourself. Perfect. All right, let's go back and look at a compare. So when you're doing a compare, that's what you would say. I would say 7 cars, 3 cars, subtract the difference between the two. And then this is the graphic organizer I would use. And we're going to get to see again Dr. Saunders show us these on a graphic organizer. Because when you first start teaching this, you're going to actually do the motions on the graphic organizer. I'm showing them here because I'm doing it on a video. But when you are working with students, you would actually have the graphic organizer out and do your motions on that. So here, if we had 7 cars, I would put out 7 cars here, 7 cars, and then 3 cars. And so what I would do is it would be bigger number, smaller number, and then I'm going to pair these together. And the ones that I have left over, I'm going to push them down here, and that's going to be the difference. That's my subtraction. So imagine bigger number, smaller number, the difference between the two. 7 cars, 3 cars, the difference between the two, and I'm pushing them down. All right, now let's look at the third type of problem. This is called a change problem. The big thing to remember about change problems, you only have one thing, just one thing. And that one thing is either going to increase in number and you're going to add, it's going to change by adding, or you're going to have one thing and you're going to take away and it's going to decrease in number, which is subtraction, okay? And so here's an example of that. Elrod was making cookies for a school party. He needed to pack 10 cookies for school. So that's how many he had. He had 10 cookies. Unfortunately, he dropped 3 cookies that broke, so he could not take them. So he had one thing, which was cookies, and he had 10 cookies. And then what happened? It changed because he dropped 3 of them and he couldn't take them. How many cookies are left for Elrod to take to school? And here we have this kind of helper phrase, but again, not going to rely on that on its own. We're going to look at the structure too. And so let's look at what that, let's see, he has 10 cookies and then 3 cookies. So let's look and see what that might look like. So it says one thing, same, and this is the sign language ASL symbol for, or motion for change. So one thing, same, and you're either going to add to it or you're going to take away, change. And so let me show you. You're doing one thing, same, and here is where you have your starting group. So if I have 10 here, I'm going to take away. If I'm adding to it, then I have manipulatives here, and I'm going to add to it. And then you push the total over, which is why you have change. And you'll see that on the graphic organizer in a moment, okay? So again, it's one thing, same. Add to it, take away, change. And imagine pushing over your manipulatives. Now let's do it together. Ready? One thing, change. Add to it, take away, change. Now by yourself. Excellent. All right. Now let me share again. And so here's the graphic organizer. And so what you want to think about is having here, you would have your manipulatives because you're going to start with one thing. So for example, you might have 10 cookies here, right? So let's do that one. And so we would say 10 cookies, same. And then we would take 3 cookies and we would say, take away, move those 3 cookies over, and then push all the cookies over, subtract, change. Notice I said subtract to tell them what to do. That is the operation that we would be using. So let's look at that again. 10 cookies, same. Take away 3 cookies that broke, subtract, change. Now, if we were doing the other way and we were doing addition, we would start by having our manipulatives here and here. So let's say we're adding 3 to it. We have 10 here. So 10 cookies, same, add 3 cookies to it, change. Because I said add, I already told the operation. All right, and you'll get to see that in a video in just a few minutes. So when you're doing your think aloud, you want to make sure that you're modeling and that you're explaining why it is that you have the specific problem type, how you determine that. And so for a group word problem, you might say something like, I know this is a group word problem because it had 2 small groups that were different things. It had cats and it had dogs. And I knew that I had to combine them together to make a big group. And that big group is pets. And then you want to make sure that you follow that up with your procedural rule always. Small group, big group, because that helps to cement that, and you're modeling that thinking. You're modeling that you want to make sure you're using your procedural rule. When it comes to compare problems, you might use a think aloud something like, I know this is a compare problem because the groups are the same, and there's a compare phrase. I see how many fewer. That tells me that this is a compare problem. Bigger number, smaller number, the difference between the two. Then your think aloud for your change problem may be something like this. I know this is a change problem. It is about the same thing. It's only one thing. I need to choose my graphic organizer. I can see that it has the phrase let's say how many were left, or let's say how many were left. And that phrase is going to tell me that it is getting smaller. The quantity or the number I have is getting smaller. So I know it's a change problem. One thing, same, take away, change. All right, so there we go. That's our think aloud. All right, if you do a quick check-in with yourself, you're doing good. I need more work on it. It's okay if you're right here, but if you're completely lost, please make sure that if you're still lost at the end of our asynchronous content that you reach out and let me know, okay? I'll see you in the next video.